Your brain is a marvel of evolution. For millions of years, its primary directive has been survival. It built an incredible model of reality, one designed to help you navigate predators, find food, and build shelter. In your everyday life, objects behave predictably. Drop a ball, it falls. Push a car, it moves. Our intuition, this innate sense of how the world works, is incredibly powerful. It's a survival mechanism honed by observing the macroscopic world around us. It tells us that things have a definite position, a clear trajectory, and that observation doesn't change the object itself. But what happens when we zoom in, far beyond what our ancestors ever needed to perceive? What happens when we reach the fundamental building blocks of everything? This is where our finely tuned intuition completely breaks down. This is the quantum realm. Quantums simply means discrete units, like steps on a ladder rather than a smooth ramp. Energy, light, matter, they come in tiny, indivisible packets. And at this minuscule scale, reality stops behaving in ways that make any intuitive sense to us. It's a universe operating under a different set of rules, rules that defy everything we think we know. One of the most mind-bending concepts is wave-particle duality. Think about light. Is it a wave, like ripples in a pond, or a particle, like a tiny bullet? Remarkably, it's both. And not just light, but all matter. Electrons, protons, even atoms exhibit this bizarre dual nature. The famous double-slit experiment illustrates this perfectly. If you fire particles like electrons, one by one at a screen with two slits, you'd expect them to go through one slit or the other, creating two distinct bands. But instead, they create an interference pattern, just like waves do. It's as if each electron went through both slits simultaneously. And here's where it gets even stranger. If you try to observe which slit the electron goes through, it suddenly stops behaving like a wave and acts like a particle again, going through only one slit. The act of observation changes its behavior. This leads us to quantum superposition, the idea that a quantum particle can exist in multiple states at the same time until it's measured. Imagine a coin spinning in the air. It's neither heads nor tails until it lands. A quantum particle is like that coin, but it's simultaneously all possible outcomes until we look. It's the famous thought experiment of Schrödinger's cat, a cat that is simultaneously dead and alive inside a box until someone opens it. Then there's quantum entanglement. When two particles become entangled, they become inextricably linked. Measure a property of one like its spin, and the other instantaneously takes on a correlated property, no matter how far apart they are. Einstein famously called this spooky action at a distance because it seems to violate the cosmic speed limit of light. It suggests an underlying connection to reality that our intuition can barely grasp. But it's not just the quantum realm that defies our intuition. Step away from the tiny and look at the incredibly fast and incredibly massive, and our sense of reality is once again challenged by Albert Einstein's theories of relativity. Our intuition tells us time is absolute, ticking away universally for everyone at the same rate. But relativity tells us time is relative. The faster you move, the slower time passes for you compared to someone stationary. If you could travel near the speed of light for a year, you might return to Earth to find decades have passed for everyone else. Length also contracts, and mass increases at high speeds. Our common sense understanding of space and time as fixed, unchanging backdrops is simply wrong. They are interwoven into a flexible fabric called space-time, and they warp and bend depending on mass and motion. And what about the very composition of our universe? Our intuition suggests that what we can see, stars, planets, galaxies, makes up most of it. But astronomers tell us that everything we've ever observed, every star, every planet, every glowing nebula, accounts for only about 5% of the cosmos. The vast majority, roughly 27%, is made of something called dark matter. We can't see it, it doesn't interact with light, but its gravitational pull is essential for galaxies to hold together. Without it, they'd simply fly apart. And the remaining 68%? That's dark energy, a mysterious force pushing the universe apart at an accelerating rate. We have no idea what it is, only that it exists, and it's the dominant force shaping the destiny of the cosmos. Our universe is mostly made of stuff we can't see, can't touch, and don't understand. These aren't just abstract theories, they are experimentally verified realities. Our brains, wonderful as they are for everyday life, simply weren't wired to grasp reality at its most fundamental or its most grand. We evolved to understand survival, not the underlying code of the cosmos. Quantum physics doesn't just challenge intuition, it completely shatters it. Relativity twists our everyday perception of time and space, and the very fabric of the universe is built from materials beyond our direct comprehension. This might sound unsettling, but it's also incredibly exciting. It means the universe isn't built for human understanding. It's far grander and stranger than we could ever imagine. We're just slowly learning how truly weird, how truly magnificent, and how profoundly unintuitive reality truly is. It's a humbling and inspiring journey of discovery, constantly pushing the boundaries of what we thought was possible.